We are obviously used to thinking of El Nino as a natural mode of variability, which it is, and it belches out heat from the ocean to create a mini global warming because during the El Nino year, the global mean temperature goes up because the ocean releases the heat that's been accumulating, uh, in the previous years during normal and La Nina years. And we know the impacts, we call them teleconnections, of the same year. Well, that's what the focus tends to be. So you look at various dry and wet regions, July to September, October to the following January, November to March, and the monsoon region, June to September. Southward of it is January to April, and Sri Lanka and the southern tip gets wet during October to December. The northeast monsoon, there is a signal here. Of course, the major signals are here, and the wildfires, droughts, dust storms over Australia, shifted convection, and landslides, floods, and massive destructions over here, and winter storms over parts of the US, etc., etc. So these are the teleconnections, and these are correlations over many decades related to El Nino, and there's an asymmetry. La Nina doesn't look exactly the same, but La Nina also tends to have many global impacts. So now that global warming is tinkering with El Nino itself, in the sense we saw 2023 as an ocean dynamic El Nino, where the weakening of the trade winds because of the warming in the Atlantic and Indian Oceans created a Walker cell perturbation, and the accumulated heat got released to create ocean dynamic El Nino without strong atmospheric coupling. Teleconnections are being changed as well by the global warming. So why not think about El Nino as a paradigm for incremental warming? Let's say during the 2023 El Nino, global warming temperature, global warming increased by some delta T, and we have all the impacts of 2023. We will look in a minute. 24 was even warmer, which is what happens. 27 will be warmer than 26 likely, and we keep arguing about crossing 1.5 degrees C and so on. So if you think about keeping global warming to a minimum, then the question is, can we predict the impacts for each zero point 0.1 degree of global warming? Because you have to go from global warming to regional patterns and the impacts in your backyard. So El Nino probably provides an excellent opportunity to do these things. So that's just an argument I'm making. So if we look now, what happened in July 2026, El Nino is already in place. By definition, it peaks in December, January, February, but the warming in the cold tongue region of the eastern tropical Pacific is very extensive and quite warm, warmer than many strong El Ninos even. So global average temperature tied with 2024 as the warmest July on record, which is the global warming. So if you made such a quick warming because of El Nino, and you get quick responses in, shifts in rainfall, floods, droughts, wildfires, and storm surges, impacts on cyclones, reduced hurricanes, typhoons are going crazy, and so on and so forth. So you can look at impacts on Arctic, Antarctic, North America, hurricane on the eastern side. Usually you reduce hurricanes here during an El Nino because of the changes in the wind shear and conditions for genesis of cyclones. Global tropical cyclones, there were 9 named storms in July, which is near average for the month. So El Nino didn't make an impact there. It's always complications. Ireland is Ireland experienced, its driest July on record. Europe is cooking with, I think, 6 heat waves this season with tens of thousands of excess deaths. Sea ice extent, lowest July sea ice extent in the Arctic. Japan experienced its 4th warmest July on record, and so on. So if you take the amount of warming related to El Nino and think of that also as an analog to global warming. Will global warming produce similar impacts? This is a key challenge. We need to figure that out, because maybe if El Nino is changing in its character and it's changing in its teleconnections, then we can just combine the paradigms and see if El Nino can work as a mini global warming with the fast impacts, because El Nino will leave many changes in the heat content and changes in the Gulf Stream, sea ice, etc., which will have lagged responses after 1 year, 2 years, and maybe multiple years. So let's just look at 2023 state of global climate 2023. This is the warming we saw. Did we cross 1.5? It unfortunately depends on the data set. Multiple data sets looked at here. Differences are larger in the past, but now they are almost together. But even small differences can mean huge amounts of change in and differences in energy, because this is global warming, right? So here we are in terms of the Nino 3.4, which reached 2 degrees C, and we are saying we'll blow past 2 degrees C, maybe reach 3 degrees C, 4 degrees C, and so on, and coined this fake term called Super El Nino. But if you look at mean near surface temperature anomalies with respect to 91 to 2020, 2023 looked like this. El Nino is right there, and you have these PDO-like responses, Aleutian low, and you have the North Atlantic response, Indian Ocean dipole-like response here. And are these all directly attributable to El Nino? Of course not. This is the part of the, the global warming hole is somewhere here, but still you have the meandering of the jet streams. You can see warm, cold, warm. And you have also wave pattern here. So you have local forcings, remote forcings. India is seen a cooling during 2023, which is a separate debate, because you have to look at which season cools. Monsoon cools, and is attributed to some response to the warming over here, and so on, right? So you are obviously, this has El Nino plus global warming. El Nino itself is going to, bumped up the global warming in 23. The debate was more about why 2023 warmed so much more than just global warming plus El Nino, which I have discussed elsewhere. If you look at seasonal averages of altimetry-based sea level anomalies, again, you expect in the early part of 2023, some signatures evolving, warm pool showing an anomaly, some anomalies here, and various other features. April, May, June, you begin to see the positive sea level anomalies associated with the El Nino that was emerging already. July, August, of course, you had a clear signature, and then you began to have lower sea levels because you had cooler temperature anomalies, and peak El Nino, you had, nice sea level anomaly signature here of the order of 0.2 to 0.3 meters, and you had dipole-like feature here with low sea levels here and high sea levels here, and the Kuroshio signature here, Gulf Stream signature here, etc., etc. And if you looked at marine heat waves, I somehow chopped off the headings there, but nonetheless, I hope that's 2023. Nonetheless, we get percentiles of the warmest years and locally, and you can see various other percentile warming occur. Polar amplification, of course, continues. Atlantic is always worth watching because of AMOC and hurricanes and other responses, and of course Pacific gets warm, and then you have associated marine heat waves. You also had cold anomalies, cold extremes, and this is the sea ice extent in the Arctic, and Antarctica had some signatures as well. So you can see that the 2023 extent in red wasn't the worst, because record low of 1979 to 2022 sits below that. So El Nino obviously has an impact on the Arctic as well as the Antarctic, and you can see that the Antarctic sea ice extent matched maybe the lowest. Antarctica is a bit complicated because you have the Southern Ocean, which kind of does different things than the landlocked Arctic. Okay, so basically the point is that now El Nino and global warming are working together. El Nino is just adding to global warming, and all the fast responses in extremes, in rainfall, in heat waves, cyclones, etc., occur. And we have to just try to learn to not worry so much about El Nino teleconnections because they are now messed up by confounding with the global warming. So you are looking here at the Greenland cumulative melt days. 2023 melt percentages jumped over in terms of percentages, and there is other time scales, interdecile, interquartile, and the median for 1981 to 2020. 2010, sorry, and so on. I'm being brief basically because I want to again stress the point that El Nino is very much a natural mode of variability, and it is very likely getting modified by global warming. Already there is a debate about whether the strong event of 2026 is because of global warming or it's part of the natural variability, and with just such a small number of samples, you cannot really do complete attribution to global warming impact. So this is the total precipitation in 2023 expressed as quantile with respect to the base 1991 to 2021. So lots of wet regions here, Pakistan, Northwest India, getting wetter these days, and you have some El Nino-like responses here. Is this an El Nino-like response? You can say IOD intercepted the El Nino impact, and you know, do you want to spend a lot of time trying to see which one is related to El Nino and which one is related to global warming, or do you want to develop a new paradigm saying global warming and El Nino together? What will they do? 2024, of course, the biggest debate was whether we crossed 1.5. Again, it depended on the temperature product. NOAA, which is here in green, was below, but some others crossed 1.5. But again, the debate is if we cross 1.5 just for 1 or 2 months and then we come back, then what are the impacts? So all the rapid responses to these kind of impacts of El Nino on global warming and the net effect on all these anomalies have to be understood. This is the ocean heat content, and you can see that Copernicus and other products do differ from each other. The point really is not to worry about the differences, but to remember that attribution is always an issue, but there is no denying that the trend is upward, and you can do this for 0 to 700 meters or 0 to 2000 meters. This one yeah, this is down to 2000 meters. That's a massive amount of heat we are beginning to store. That's not going out to space, right? So ocean is able to belch it back out at some frequencies that we have to watch out for. So the 2024 Arctic sea ice extent is shown again with and Antarctic. I won't go into the details, but the point again is El Nino created the warming of 2024, which stood as a record. 27 is very likely to break that record, and we'll again be debating about 1.5 degrees C and so on. So 2026, we have almost stopped talking about global warming, and we are screaming about super El Nino. Next year, we'll start screaming about crossing 1.5 degrees C. The point is, what can you do about predicting impacts at hyperlocal scales? That's the tricky part. Okay, so typical impacts of El Nino precipitation in January to June. You can try to compare that to these figures and try to see how many are directly related to El Nino and how many are not, and so on and so forth. Okay, so India here, January to June doesn't show much, but you can have pre-monsoon impacts and heat wave impacts and so on and so forth. This is is 2024 warming anomaly. The warming hole appears. East Pacific begins to recover from the El Nino and go into its cooling trend, and Indian Ocean continues its warming trend. Indian subcontinent begins to cool again in the annual, but as we said, we must really always look for seasonal warmings, and this is the annual precipitation 2024 expressed as percentiles of 1991 to 2020 distribution. So now we are not talking about El Nino, right? We are talking about 2024. So this wetting and is related to the warming here over Europe, Mediterranean, West Asia, and the shift over of winds over the Arabian Sea, Pakistan floods, Northwest India floods, and so on. So you are looking at annual precipitation, but still those are related to the summer precipitation signals. And you have Amazon drying, very dry. In fact, here these dark brownish colors are very dry, so less than 10% in terms of the range of anomalies, annual precipitation anomalies. US signal gets a little wiped out, but you know very well that there are massive drought and wildfire signatures all over the place. In fact, 2026 early part, there were wildfires pretty much in both hemispheres, very extensive from North America into Europe and in the southern hemisphere as well. Okay, so again, how much of the El Nino signature from 23 was left over other than the warming signature, which we expect, but what about the impacts, right? So there are fast responses in the El Nino year itself, which you try to understand with the correlations to Nino 3.4 and so on, but we are saying they are being confounded by global warming and so on. So best estimates of current global warming remain below 1.5 degrees C. This is the three methods used, methods for establishing an up-to-date estimate of current global warming as of 2024 compared with the IPCC AR6 methods. Let me not go into that, but we'll come back and look at those maybe later. But essentially, we begin to analyze everything as if they are separate. Global warming impacts, El Nino teleconnections, and residual components of the El Nino. So shipping aerosols, East Asian aerosols, Hungatunga. So this is trying to explain why 2023 warmed so much more than just global warming plus El Nino. And these are the 2024 residual components. So you can see the El Nino range got all positive here, and you have combined warming, which was 0.09 in 2023, but it's 0.23 here, and the actual warming was 0.26 here and 0.18 here. Something similar will happen in 26 and 27. I'm recording this in on 17th August 2026. So the main point of this podcast is to really just show the extremes from 26 so far, from 23 and 24, and argue that El Nino is very much now a paradigm for rapid global warming during that year, and look at all the responses and try to understand how warming in the future may begin to appear in local impacts and what we should be ready to predict accurately, because how well did we do in predicting the wildfires, the floods, the cyclones, and all other disasters. Okay, so it's a point that I feel passionate about, but maybe not everybody agrees. I will leave it here. Okay.